I guess I should do something now. So, welcome back. We are going to build on what Rana talked about this morning and talk a little bit about what we've been doing on an agentic AI front. But before I go into that, hopefully everyone's enjoying the show. It's been a lot of, I think yesterday was pretty packed. Today should be very exciting. So my team, one of the things my team does is actually put the show on. So if we could get a round of applause for Nicholas and Connie, who kind of put all this stuff together. So we are going to talk about agentic AI. Well, I'm actually not going to talk about it. The team that did the actual work is going to talk about it. I'm going to do a little bit of context setting. So Venkat yesterday talked about the innovation that's driven out of this engineering team and out of this region, and it's fairly amazing, right? I think you're all familiar with NSO and the 10 years of work that's gone into building that out. But one of the things we do that's not really fully appreciated, I think, is the speed and the agility at which this team operates, right? So when we built the workflow product, we went 12 months from our concept commit, which is our internal milestone to decide to do something, to our first customer. And that's pretty, I think for a company of any size, that's actually pretty impressive. For the things we talk about today, it was October. We had our first meeting, not too far from here, and said, hey, this is a thing we should build. And to be honest, we weren't really sure if it would pan out, but again, we're going to be less than a year to go from kicking around some concepts and kind of arguing with each other to shipping a product. And the things we talk about, we'll have shipping code, towards the end of the summer. So when we built this, our internal project name is Project Foresight. This is our little pirate crew. There are a couple of things we had in mind, which are kind of some of our first principles around the project. One of which is we were firm believers in the concept of agentic AI, which is all over the place now, but a year ago that was actually fairly exotic and fairly rarefied. And we think that has played out, and I think you'll see that over the course of the next hour. The second is we were actually not looking to ship a new product or a new platform, for a couple of reasons. You've all invested in Cisco platforms, Cisco tools, those kinds of things, and we didn't want to come to you and say, hey, here's a bunch of cool new stuff, but here's a new thing you need to buy or a new thing you need to integrate. So the things we talk about, the things we build through this framework, it'll either show up as features in existing products like CNC or NSO or HCO, or they'll show up as skills in the Cisco AI Assistant. So these are almost like back-end capabilities that'll show up in multiple places within our Cisco portfolio. The third thing we really talked about was data, right? If you can't have an AI conversation without talking about data. And one of the more memorable course corrections, at first we thought, okay, this is a great opportunity. We'll start pulling everything together. We'll build a data platform. Everyone will move their stuff here, and it'll make it really easy to build agents and do cool AI things. That'll probably last about 6 weeks, and we got pretty uniform feedback saying, we're not going to do that. That's never going to happen. So one of I think the unique things about what the platform we built is built around the concept of federation. It's built around working with your data where it is in the tools and the repos that you already have. So we've built this to be able to find data wherever it is and be able to work with it. For NSO folks, we have the concept of NEDs, which allow you to build service code and not worry about the actual infrastructure is going to run on. We have the same kind of concept with what we call data retrieval agents, where we'll find the data wherever it lives and be able to pull it in and federate it, clean it up, and send it to our agents. Finally, we built around SDKs. I mean, we're proud of what we built, but at the end of the day, much like NSO, much like workflow, it's a platform. We will build cool stuff on top of it, but really we want to enable you all to be able to build use cases, build agents, build those kinds of things, and kind of drive your own destiny. So for the next 45 minutes or so, we're going to go through this. If you have any time at the end, we can do some live Q&A and try and answer your questions. Otherwise, we all have these snazzy white T-shirts on, so if you have any questions afterwards, just tackle one of us, and we'll try and be helpful. So with that, I'm going to introduce Javier, who is our chief mad scientist. He laid out a lot of the vision around our agentic, our agentic framework and kind of the direction we should be going. So, Javier, I will hand things over to you.
Thanks, Omar. I hope you can hear me. And apologize for my voice, but I have a bit of a sore throat. So really excited to be here this morning talking about something that we've been working for some time. And I want to dedicate this next few minutes to kind of go through what is, the background. Why are we doing this? I mean, we're talking about agentic AI, and everyone is talking about that. So what really connects agentic AI with what we need as an industry, right? And I think the start point, and I like to visualize it in this way, right? TM Forum and others, we've set this ambition, this goal of the autonomous network, right? And what does it mean getting to this level 4, level 5, levels of autonomy? It's just about doing automation, more of what we do already. Probably there's some of that. But there's a fundamental shift. There's a fundamental evolution. It's not a replacement, it's an evolution from automation as we know it to autonomy. We need to understand the difference between the two terms, because that determines what is it that we need to do different, or what is it that we need to do in addition to what we do today. So automation as we know it, it's mostly driven by rules, by some form of rule created by us, by some form of artifact, whether it's a rule, whether it's a template, whether it's a workflow. It's always driven by us and how we code our knowledge into those specific use cases that then are executed. Nothing negative about that, by the way, but it's inherently limited in scope. And because it takes an effort to create those rules, those artifacts, automation only focuses on the head of the curve, the most frequent things, right? The most frequent use cases that we can address in that way. But there's still a longer tail of situations, use cases that cannot be addressed in that fashion, because you cannot create rules for everything. So bridging into autonomy means unlocking the long tail of use cases. It means building systems, methods that can somehow understand, that can somehow observe, what is the environment and make decisions that can adapt, right, in some way to changes. And that means not being dependent on rules. It doesn't mean that you cannot use rules, but it means having mechanisms that will allow you to act or to make the right decisions even in the absence of those rules. That's what autonomy means. And when we think about reaching the level 4, level 5 autonomy of the autonomous network journey, that's what we need to unlock. So now the question is, this is still very abstract. This, what does it mean? Observe, understand, adapt. This is about LLMs. Not necessarily. It could be, right? But it means using new technologies that we haven't used so far. It means doing new things in addition to what we are doing. We're not gonna stop doing what we do in the context of automation. We will have to do new things to unlock the long tail. What type of things? Well, just a few examples, right, from different use cases. And again, these are just examples. There's many other, examples of use cases that are familiar to you that you go and execute, drive in your network operation context, alerting, correlation, compliance, troubleshooting. These are just things that we already do. And the way we do them, in one way or another, it's based on rules, as I was saying, rules, templates, workflows. We need to transition now, or we need to add a new layer of ability or capabilities that will enable us to address the requirements for autonomy. And depending on the use case, the approach might be different, right? There might be certain machine learning algorithms that will allow that transition. But in many cases, we're going to see moving forward that there is a new building block that might play a key role in this transition, and it's the concept of autonomous agents or AI agents. So we'll double click into this, but just keep in mind for the moment that machine learning and agents will play a key role in this transition from a rule-driven automation to a goal-driven automation. That is what autonomy means. Last year in the NVIDIA event, Jensen Huang made this kind of a statement about how he thinks the future of software development will look like. Probably it's not even anymore the future of software development, it's actually even the present of software development. But the way he was articulating is, hey, there will be a set of AIs or a team of AIs, in this case AI means an agent, that will get the mission, right? What is it that needs to be done? We'll break it down into an execution plan, and then we'll use perhaps a specialized agents or AIs to execute the different parts of that plan. This is how he was describing the future of software development. So if that is the case, and we are already seeing a lot of symptoms or signs that this is actually even mostly the present, there are a lot of parallelisms with what we do in the context of network, right? Network operation and network automation. So we could think, hey, this might be a reflection, or there might be a lot of similarities in what we should do, or how network operation in the future might actually look like. The current scenario of network operation is something like this, right? You have the network engineer interacting with a lot of different systems, automation tools, inventory tools, observability, monitoring, right? All these different systems that network engineer needs to master in some way, so there has to be sufficient knowledge, and every interaction is time and cost in order to do any type of activity, whether it's troubleshooting an issue, whether it's getting an answer to a question, anything that is done on the daily activities. So can we think that perhaps the future of this network operation context might look something like this, right? Where that network engineer, instead of having to interact directly with all these different systems, can get the support of an intelligent agent, and keeping it just generically like this. But that intelligent agent is the one that knows how to interact with all these systems, how to find the information that is needed, or perhaps even how to execute certain, maybe more complex processes like troubleshooting on, doing root cause analysis, etc. That's the hypothesis. Could the future of operation would, look like this, right? If it could, then it would definitely be, very interesting, because it would allow network engineers to actually delegate and offload a lot of activities and be able to, parallelize and be able to be more efficient and to do more with the same, right? So this is perhaps the ambition. So what we have ahead, and Rana was showing this slide earlier, is this transition, this evolution from automation as we know it today, mostly driven by artifacts that we create manually, to an environment where agents might play a fundamental role in enabling decisions, but those agents need to have the skills to interact with the systems underneath, right? With the controllers, with intent management systems, with observability tools, etc. So instead of we collectively investing in creating rules, we will invest in creating the skills necessary for the agents to make the right choices. But it's extremely important also for an agent, in order to make the right decisions, to have the context in which it is operating. So we're going to see more and more the importance on how do we give agents the proper context, the proper situational awareness of the environment in which they are operating. And that's the concept of a digital map or a network knowledge graph. So that's going to play a fundamental role in enable the proper reasoning for agents about the issues, the goals, the requests that we made to the agents, right? But all this combined will allow us to scale from, the current automation to a much, let's say, ambitious, stage or level that aligns with those goals of level 4, level 5 autonomy. And this is precisely the roadmap that TM Forum has, outlined as part of the level 4 autonomy blueprint, and in terms of phase 1 and phase 2 of that autonomy. Now the question is, okay, if we assume that is how the future of automation or autonomy looks like, how do we make this real, right? What is this agent thing? It's a software, it's an application, it's a VM. What is it? What it runs? How do I manage it? How do I deploy it in my network? Immediately when you see this slide, you have to answer those questions, or those questions will appear. And that's precisely what we are trying as a team to address. How do we make this future of, agent-based network automation production ready, something deployable, something that you can deploy and build in your network. And that's precisely the multi-agent framework that we are working on. It's about making agents for network automation a reality. Whether it is the agents that we build, right? Because of the use cases that we have identified by talking with you and that we can productize, but also enabling you to create your own agents through the availability of the different SDKs that will empower you or partners to create agents for different types of use cases. But it's not, an agent is not just a software process, it's a system that needs to be managed. There is a life cycle of an agent, there is an agent ops set of requirements that's key capabilities that the platform will bring so that you can manage the entire life cycle of these entities and eventually deploy them successfully for your network operation. And this is fully aligned, if you have heard, with the Internet of Agents vision that Cisco has been sharing for quite some time, through Outshift organization, which is a sort of research branch in Cisco. Ultimately, that vision sets a future where agents will play a fundamental role in a very distributed way in our lives, right? Now, contextualizing that to network operation, right? And to deploy agents that can run effectively in a network operation context. This is what this framework that we internally call foresight is about. And that leads into that future operational ecosystem where you still have all those different tools that I was describing earlier with your observability tools. Of course, this is our Cisco portfolio, but it could be anything, right? Any third party, right? You have our observability tools, your action-focused tools like Workflow Manager or NSO. You have your controllers. And then you have that new logical system, which is a little bit of orthogonal to all of them, which is where agents run, right? And agents will enable us to start moving forward, more and more closed-loop use cases. Instead of closing at the human level, they might eventually close at the agent level, right? And by doing that, we get, progressively, we move forward towards those more ambitious level 4, level 5 levels of autonomy. And in our case, through the Cisco AI Assistant, unified conversational interface, we will provide the user, the human operator, with the ability to interact with the agents in a natural interface way. So this is the ambition of what we want to build, the future that we want to enable from an operational point of view. Now the next step, of course, is to start, filling this with agents that can, help you in your network operational context, some of which you already saw, and you will see some more details now in the next few minutes. Okay. So,
thank you, Javier. So I think one of the things, just to give you a peek into our product development process, and hopefully some of that came through, before we ever get to building things, we try and have a couple of more foundational conversations. One of the things Javier touched on, we spent a lot of time trying to figure out, okay, how will you work in the next 5, 10 years? What's your day? What's a day in your life look like? What kind of challenges will you have? What kind of struggles? What kind of problems you need to solve? And kind of use that as a as a foundational piece before anything that we build and design. The second piece, which we're going to talk about now with Eleni and Martin, we were also big believers in having some strong foundational principles that guide everything. We're not generally a team not to go chase features and do those kinds of things. We try and have some foundational principles that shape everything. And if you look at something like NSO and say, hey, why is NSO still relevant after 10 years, which is a lifetime in terms of software tooling, is because, a decade ago, the founders created a set of strong principles that guide this is what NSO is about, and we've stuck to that. And it's, we really believe it's a key to, maintaining purpose and vision, but still being flexible, right? In 10 years now, 10 years forth, it's a different world, but the principles made a whole lot of sense. So second thing we spend a lot of time on is design and architecture, to build an architecture that's not just about delivering an agent now, but something that will also last for 10 years. So with Eleni and Martin, we can dig a little bit more into that piece of things. with the clicker.
So at the heart of autonomous systems lie autonomous agents, which are self-contained entities designed to run in a well-defined agentic framework. Now, these come with a set of goals, associated skills to achieve those goals, as well as contextual awareness. And it's good to be specific, right? So when it comes to defining goals, these have to be strictly defined, but they can have a range and different flavors in terms of what these goals are. So these can start from very simple ones to more aspirational goals and more elaborate ones. So for example, as we'll see also later on, one of these goals can be identifying anomalous configurations. Now, when it comes to the associated skills to achieve those, again, these can be very simple tasks, even rule-based ones, right? To more elaborate analysis capabilities, such as following the example from before, such as scouring through rivers of configs and trying to figure out what patterns are there, and then finding out those anomalies. And of course, it could also be more involved decision-making skills. Now, in terms of the context that the agents need to be aware of, it depends on the use case. So, for example, it could be being aware of device inventory. It could be knowing about topological characteristics, but it could also be understanding segment routing policies and so on. So the context matters a lot for the different use cases. Now, when we have a set of agents with those different characteristics, in order for users to actually be able to access them, these agents need to be maintained in what we call an agent catalog that keeps track of all these characteristics. But it's not just users. If we're thinking multi-agentic frameworks, these can also be used by other agents to achieve more involved use cases that span multiple of those goals and objectives, right? So taking a step back, now that we talked about the agent catalog, let's look at the other foundational building blocks that need to be there from a functional perspective. So at the heart of this is the knowledge base that Javier also touched on. And this is really about capturing a representation of the network entities, their characteristics, as well as their relationships. And this has to be, of course, constructed, as well as maintained over time in order to provide agents an up-to-date view so they can make then informed decisions. So these agents can be spun up from what we call the agent instance manager, which is basically responsible for CRUD operations for agent instances, as well as managing them over time, including also health and troubleshooting aspects. Now, we also have what we call the agent instance job manager, which is really about handling jobs for long-standing agent instances. So aspects like scheduling and queuing those jobs, right, for the agent instances. We also have, I think, a very important component to mention is the transparency and explainability service. It's important to be able to access logs and also traceability aspects when it comes to, if you think about dialogues between agents and LLMs, as well as their corresponding APIs and actions that are being taken. So all of this has to be logged and traced, right? So finally, we also have what we call the agent evaluation service. So it's very difficult to be able to understand how well or badly an agent is performing unless we properly evaluate it and test it in the environment and for the use case that it is intended to. So that's where the evaluation service steps in to facilitate that. And it's very, very helpful to be able to understand and track the agent fitness also over time as conditions change and also LLMs involve, as a matter of fact. So, and of course, it goes without saying, the LLM service, from the platform perspective, it's important to provide access to LLMs in a unified manner from the platform perspective. And I didn't touch on the inter-agent communication aspects. So of course, when we're talking about a multi-agentic framework, these all need to be handled and by the components mentioned before. So.
All right, thank you, Eleni. Hi everyone, I am Martin Kjellin, and as you can deduce from my slide game, I am from the engineering side of things in this organization. So I was gonna try to give you a little peek under the hood of Foresight, as well as kind of explaining a little bit on how you might interact with it. So as Rana mentioned this morning and has been mentioned throughout this talk, it will primarily be you will access this through the systems you already have and hopefully love, or in other cases that you will hopefully soon acquire. So the gray box up there can be NSO, PCA, or HEO, or CNC, of course. And inside the blue box here we have an overview of the current state of Foresight components, slightly simplified. We have some gateway functionality, but already here I'd like to mention that we are building everything for distributed development and things that it will scale out widely. So we're bringing a micro front-end service so that agents can dynamically generate the UI on the fly. It's not a fixed UI in that sense. It's up to the agents to decide how they want to display the results. There's a control agent that does task decomposition and planning and all the fancy things that makes agentic AI very, very, very interesting. And then we have what we sometimes call task-oriented agents that perform a specific function. These are the use cases that has been outlined so far. As well as we provide and bring the possibility to do your own data retrieval agents, which acquires the information that Foresight needs for its use cases or for its task, rather, its intent, from surrounding sources, be they CNC or NSO or PSA or whatever is needed, and we update this as on a need-to-need basis in our central knowledge base. And LLM interaction might happen at any of these stages at all. We are also having, as Eleni touched upon, we are bringing an agent catalog or an agent directory where you can register your agents and announce their capabilities. As well as, if you please, you can define APIs to directly interface with the agents. What I also like to mention here, of course, I was already first sentence talking about UI, but since we're heading towards autonomy, you might not always even interact with your agents directly. You might have autonomous agents which notify the results through our notification service. And speaking of principles, a couple of things that we have from the engineering side, keeping in mind at all time when we built the system in the last months, is one of the things is like we're trying to be mindful of resource use. You see some boxes are blue and some are white, and that's we launch instances on demand. So at rest, this is a very friendly system in terms of resource utilization. We are at the moment kind of flexible in integration. We are definitely keeping a close eye all the time on the classification of data. So a risk here when you have autonomous agents is that data might flow in various directions. Agents are communicating with each other and retrieving data. So we are at all times keeping a mechanism to ensure that data doesn't go anywhere where it shouldn't go, and that's what I try to communicate by having one sole error to the knowledge base, but it also applies to interagent communication. And of course, everyone wants to know what happens, so tracing, logging, distributed logging, all those things is in place from the get-go. And with that, I'd like to say thanks for me.
Thanks, guys. So Eleni and, yeah, good point. So Eleni and Martin have done a great job. So they're the architects on the team, and they've done a phenomenal job taking some vague concepts and really turning them into an actionable blueprint that's allowed our developers to start coding things. So you've had 30 minutes of theory. I'm now going to invite Nils Petter on, who is the PLM for the project, to start talking about what we're actually building. So Nils Petter.
Thank you. And I really don't understand what you expect from me now. It's still theory. So anyway, hopefully you can see, yeah, you can. And you probably recognize the slide as well. But I think the few things that I would like to talk about is really how do we think about what kind of use cases. Martin and Eleni talked about the architecture, which is really driven by what we need to achieve. And starting from augmentation, like really to help network operations to make more decisions, more informed decisions, more quicker. And the journey here, on these developer days, we've always been talking about automation journey, network automation journey. And the typical bump is people and processes, maybe not technology. We'll see that's happening here again, because we're taking a new journey, or a concurrent journey, and we'll see some doubts about, is this for real? Can we trust the outcome? Etc. So hence, the first use cases we focus on is really to inform, make the vast amount of data in the network, in the long tail that Javier talked about, to actually be more understandable, to make the decisions. And then building the trust, but also technology, because we all know that the AI technology, it's progressed very quickly. A lot of changes going on. And then moving into more and more autonomy in the network. So yes, in the road to fully autonomous networks, that might happen somewhere in the future, we have multiple steps in between. And in the end, we have a simplified operation lifecycle about full automation, but simplification is a guiding word on the entire route. Okay, so from a product management perspective, trying to understand what these agents are all about, how they interact, is also a challenge and kind of interesting. So I have an example here for how to understand and check for autonomous, anomalous traffic, whatever that might be, if it's a strange pattern, you have a lot of DDoS, you might have traffic going berserk, and trying to break down that into different agents. Javier mentioned that it's a multi-agent framework that we'll end up with, but that means that you have many agents interacting with each other. So, and we also talked about Cisco AI Assistant. Why do we talk about that? Yeah, because whatever kind of AI agent and AI interaction you have with Cisco products, you will have a unified user experience to interact, chat, whatever. So we use that as an entry point to understand, ask a question if I have any anomalous traffic in the network, very unusual, very wide open question. We break that down to decompose that into different agents. So the decomposition function or agents in our framework. And the next step is also super important, because we need to have the historical data and current state. And why do that's important in our framework? Because we are using the existing controllers out in the network. We talk about using NSO, CNC, PCA, etc. But we also have data retrieval agents that can interact with your favorite, like event collection system, whatever you might have there. It seems to be very popular to have your homegrown event collector. And that means that to be able to feed the agents, both with historical as well as current state, we need to interact with that and provide that. Agents know everything about data, and using your favorite AI tools, you see that it's all about unstructured data. That being said, we need to be able to correlate in between the different systems, hence we put a lot of emphasis in our knowledge graphs and to be able to normalize our data sources. Then we have a core agent that actually determines if there is an anomaly. As Martin told you, that might scale or need to scale horizontally, depending on the load and the massive amount of data. And then we have the decision of how probable is my conclusion here as an agent. That's the next function. Last but not least, it needs to be readable. I need to be able to consume this as a human. And we go back then to the Cisco AI Assistant. And once again, Cisco AI Assistant can then be attached to any of the Cisco products, or you'll use that. And also important to remember that everything we talk about here, especially for those of you who are used with NSO, we expose all the capabilities in our SDK and APIs later on. Okay, a very high-level roadmap. So everyone have talked about the first two use cases, so we'll skip that one. I think it's a little bit more important to go in what we're seeing ahead of us in half a year. Copilot for incidents, helping out troubleshooting with our friends. Automation adoption, or an automation developer agent. That might be very interesting for this audience. Actually, a session later on today about how to streamline or develop first phase NSO assets, young models, your templates, Python code, etc. Actually using some parts of the framework we're talking about here. Super exciting to actually make the time to market for new services much quicker. Moving on into the future, we see the need of all over the place of use cases. Rana fired up a Slido about your suggestions for future use cases. So we'll capture them, and this is really ask you to visit us in the booth after the break, because we'll have a Slido where you can rank all your suggestions and our suggestions. A few things that I would like to more highlight is when we look out further on in the true multi-agent framework, and when we go at more maturity, we will be able to do more elaborate questions like to optimize my network for better video performance on a very high level, and then following the flow that we just saw. And that will need the data and analysis from very many different nodes. And then we'll come to a fully fledged recommendation that you then can deploy. But once again, important to remember, and that could be then create a fantastic closed loop automation. That being said, we have a lot of things to learn before that. So we'll starting with read-only, where we are today, and then going to prescriptive actions that we actually can deploy. Final words from me, very important to remember. We do extend our existing product catalog, as you don't need to struggle to order new products. The first few use cases for NSO and CNC, you will see later on today. And super happy to talk to you later on about your favorite use cases and what you see that you need in the future. Please visit us all in the booth. And now to some real stuff, I guess.
Yeah, come to the booth. You can ask us questions. We have stickers, which is for your laptops. So finally, we're going to close with some running code. We have demos, as we've talked about. Our first two use cases, Toxic Factor and Config Drift, will be FCS shipping in the end of September. And we have some previews that Frida and Shaharsha will take us through. So Frida is our engineering lead, and Shrahash is one of our TMEs who's been central in the whole product development cycle.
So thank you so much. So I think we had on the agenda to talk a bit overall on the two agents, but I think it has been a lot of discussions about them already. But what I want to start with, and what is nice been going last, is that I can hear about all the things we have actually done in a very short time. And there are a few people here, and I think over there. And I want to give a shout out to Erdem Aksu and Tien Lee, who are here today. Please, guys, stand up and give them an applaud. So both Tien and Erdem are two of our key developers for developing foresight and actually made this happen. So I think I had a slide, but I think I will leave it soon to you, Sharsa, to actually show. But as you will see, we have focused on two very practical agents for your day-to-day operations to gain performance and stability in your networks. So with that, thank you, Sharsa. Go ahead.
Sure. Thanks, Frida. Hello, everyone. My name is Sriharsha, and I'm the TME for the Crosswork Foresight project. Today, I'm here to demo the two agents that the team has built in the past 6 to 8 months. So today, we'll get started with the toxic factor demonstration. So as you see, this is the landing page of the AI assistant that the team is building. Oh, just give me a minute. Sorry. So that's another demo. So, so this is the landing page of, I'll just rewind it. So this is the landing page of toxic factor detection. In this demonstration, we are trying to look back on the events in a time period of 6 days, and we are trying to correlate with the BGP session down events in the network. Typically, what happens in this case here is it's making a call into your controllers, and it's trying to fetch the details of the events that have occurred in the past time period that was mentioned there. In this case, it's the last 6 days. And as you see, once the analysis is done, a report is generated. And in this report, we have identified two particular factors. One of them is we categorize it as major, and the other one is moderate. And we also provide you information of how many days, what time period we collected this data, and we did plot the frequent patterns that are present in this particular thing. In this case, it's around 912 devices, and the events that we checked are around 21,000. And as you see the speed of it, it's less than like few seconds, you know. So the analysis was done, and then we identified a couple of toxic factors which are based on a specific software version, and that we are saying it's a moderate thing under toxicity. And the number of devices that are affected due to this one is around 33. Whereas the one that is with major is in the same software version, but it's including a specific hardware revision. And this particular factor is available or like seen on your network in around 12 devices, and that is causing a lot of BGP session down events that are happened in the past 6 days. So as you see this particular graph, what we are trying to teach you here, or what we are trying to inference from this graph is, in the last, let's say from 17th April to 19th till 20th April, everything was working as expected, normal, and we didn't see any outliers. But from 20th to 21st, there was an upgrade of the software that has happened. And in this bunch of devices, everything was working normal, but except these devices. We were able to predict them by saying that this happened only on this specific devices, on these 12 devices. The reason is, there is on this 12 devices, the inventory that the 12 devices are running as an hardware version of 39548, and it's along with a software version of the new software upgrade. This particular combination is kind of causing some network down, or like the BGP down events in the network. And so we are able to predict that, and we are able to pinpoint it to this exact 12 devices that are of our interest, or like you are able to find your hotspots in your network by running our agents. And in this case, you can export the data, all this data as an CSV. We also have you can ask the agent to explain the results that it plotted, and you can export the results as well. With that being said, the toxic factor demonstration is completed. And let's go ahead and look at the config drift demonstration. In config drift, what we are trying to plot is we are trying to figure out what misconfigurations are present in your network on a bunch of devices, or like on your whole network elements. So let's get started. This is the landing page, and here we are running the config drift analysis. We are selecting the group of routers or group of network elements that are of our interest. When you click analyze, what is happening behind the scenes is it's actually looking through the knowledge database and then fetching the, let me pause it here. And then it's fetching the devices of that specific logical group, and then it's connecting to NSO. And then from NSO, it's fetching the configurations of all the devices, and then it's analyzing it based on the models that are pre-trained as per that specific logical group that has been present. Once the analysis is completed, it provides you a result overview. In this case, there are around 235 anomalies in 123 devices. And in these 123 devices, these misconfigurations are present on only 13 devices. And the result has the very specific details. Once you expand on each device, it will tell you what is the misconfiguration that is present. In this case, the one that we opened up here, or that we expanded here, has 3 misconfigurations. One is like it has an extra line, and then something is missing, and one thing is incorrect. Like as an example, in incorrect, the MTU is configured as 150, but the expected value is around 1500 and more. So, and again, we also plot the confidence level of the agent of high or low based on the trained model here. With that, the demonstrations of configuration drift is completed. So any questions? Okay.
Or not? No. Okay. So a couple of things, just as we wrap that up. We've really, when we started looking at the roadmap, a couple of folks have accused us of being a little boring in terms of the things we chased. And we looked at it a little differently. We really, there's no shortage of hype in AI right now. And we tried to take a slightly different approach and really be grounded on KPIs you already care about in your business, and doing things that maybe are not as sexy, but we think ultimately be very useful very quickly. And that's really what's driven this. And it'll go where it goes based on the kinds of things you ask for. But the team's really focused on trying to do things that'll be immediately impactful. The second piece, especially for folks that are used to using NSO and looking at config drift, the question is, well, okay, I already have compliance checks built into NSO. Why do I need this? And there are a couple of pieces. Part of it is we see this as being a complement for folks that are using NSO, because it'll end up catching things that compliance checks in NSO won't. But it's also useful just in terms of showing how AI works differently and how that can change your operational approach. The traditional compliance checking is very empirical, right? It's very definitive. Here's a list of my what I think my config should look like. Let me look at what's there and do a diff and then generate a report. And that works really well, but it also takes a lot of work, right? There's a lot of setup. You need to maintain your templates. You need to run the reports. And what we're doing here is completely different, right? It works very intuitively. It looks at, and it needs no setup whatsoever on the front end. You can run config drift on devices you've never seen before, as long as they're consistent, the same type of device. So it might be a Cisco device or Juniper. It doesn't even have to be a router, right? Anything with a config file. And it uses the same kind of human intuition that you would use to understand, oh, okay, this is different than the other things, and maybe that's not right, and let me report that. So we see this as much trying to exercise the evolution of the operational models that are using AI as much as it is actually delivering products and solutions. So with that is kind of our end of our presentation. We have about 10 minutes. If there are questions, we have a runner. Thank you with the mic. So if there's anything you'd like to ask, we will endeavor to answer. Otherwise, we'll give you 10 minutes back. I can't see
Way at the
anything, so
back.
someone else left. Y'all can come up here too. I'm not answering them by myself.
Thanks, Omar and team. I have a quick question regarding the integrations or a seamless interaction between the agents into Foresight. So, Team Forum, for example, when they identified the deployment of AI and ODA, they have identified this concept of ontology, where agents will have a specific syntax to talk to each other and to be able to understand the capabilities and which tools they are using and so on, in order to align for level 4, level 5, right? To have this seamless interaction between the agents. So how Foresight is going to have this kind of integrations and seamless interaction between the agents moving forward, or it will be always through a controller who is going to get the intent and distribute the tasks? Thank you.
Yeah, so maybe I can start. We haven't gone into a lot of detail, but one fundamental, and I say fundamental really in capital letters, of the whole architecture is the knowledge graph. The knowledge graph captures the common understanding of the entities and the relationships, the actual implementation of that ontology that should be common across the agents that are running on the system. So the enabler for that, intercommunication of agents, across agents, and having let's say a common language, a common semantics across whatever they are doing, it's actually that knowledge graph driven by that, ontology. So that is the fundamental building block, and in many cases, actually, the communication will not even happen directly between the agents, but agents acting over the knowledge graph, changing state, and that will trigger other agents to actually, respond to that. So, fundamental enabler for all this transition, it's the knowledge graph and a well-defined ontology for those entities.
I think one of the things, the underlying question, we really want this to kind of run itself, right? So agents should not need to be hand-wired to deliver a use case. So we talked about Outshift largely because they give us some standards that we can use around things like inter-agent communications, things like agent catalogs. So the agents themselves can understand, okay, I need this kind of information. The planner can figure out, okay, this is a use case. Let me deconstruct what kind of information I need and what kind of operations I need to deliver this use case. Go to the agent catalog, figure out which agents support that. Go, let the agents do their thing. Even use the planner and the agent catalog to figure out which agents have the information that can retrieve the information I need. So, that's where we started. We want these things to run by themselves programmatically, not to have people involved to make things work, because that kind of defeats the purpose. The questions you got? Thank you for the logo. The logo was a joint effort. We're proud of it. Didn't we give it a name? I forget. For the owl.
I don't know. Foresight.
Okay. It's been a long time. What platform does this run on? Great question. Go straight to Martin.
All right. Hello. Right. Right. So right now we basically assume an existing Kubernetes. That's the platform that we assume. Everything else we provide. That's the platform for our execution environment is Kubernetes. We don't have additional platform deliverables at the moment, which is outside the Foresight. So the short answer is Kubernetes. The long answer is come and see me at the booth.
Thank you. I have a question in the room.
Yes, this looks very good. One question from my side is, maybe I didn't catch it. Is there going to be some kind of beta or preview or something that we can become part of during the testing phase or pre-release? Maybe to test it in the field, to give you feedback?
Absolutely. Nils Petter, put your hand up. So we're hungry for data like any other AI team, right? So anyone that would like to participate, get a chance to play with the code, come find Nils Petter, and he'll happily chat with you.
Nothing more to add. See me at the booth.
Let's see, is Foresight planning to use MCP or external resource calling, or is this part of the data retrieval agent? Someone will answer the first part, I'll answer the second part. Are we going to use MCP? Have we decided?
Yeah, I mean, I think the case of MCP, probably the industry is already converging towards using it as a tool calling standard. So we'll probably align to integrate tools using MCP. And there are other protocols out there coming up for different types of roles, which are probably less solid, or the support of the industry needs to happen first. But definitely MCP, it's part of what we are planning to do for tool integration.
Yeah, I mean, I'll be honest. Architecturally, yes, we'll have external tool calling. I think one of the things we struggle with as a team, there's so many standards that are, seem like they're spawning every day. It's really for us trying to figure out, okay, what should we put our time and effort behind? Which of these is going to get some legs and get adoption? We're really trying to build something that'll work with the majority of tools and protocols that are out there. So data retrieval agents are an example of that. So data retrieval agents are almost like NEDs for us, in terms of we'll have data retrieval agents that are built to pull information from a specific platform, whether it's our tools like HCO or NSO or CNC, or your tools, right? We'll build NEDs the same way we'll build data retrieval agents the same way we build NEDs that'll work with your data in your particular tool. That's part of that's part of why we see this being an extensible platform. Where you can build, with the SDK, you can build your own. But it's also how we also make sure your data stays put on your premises and you don't have to move it around. Is there a question out there? I see mics going around. Yes. Don't be shy, because I can't see anything because of the lights. So feel free to put a hand up or.
Yeah. Hello.
Hey.
I just have a question about the data retrieval agents.
Mm-hmm.
Are they sort of fine-tuned LLMs, or are they just using the same LLM that you provided? Because on the graph, the LLM was a separate part of the architecture. So is it prompt engineered, fine-tuned, custom model, or?
So keep me honest, but right now they're literally just querying existing, for us, for NSO and for CNC as examples, they'll just query the existing data stores. They're not LLM based. In the future, they could be.
Okay.
But just to add on that, right? There's never going to be a single LLM that works for all use cases, right? There's different types of LLM, different capabilities, different even cost points. From a foresight perspective, the LLM is in most of the cases an external system that can be configured and be used. And depending on the use case, maybe it's one LLM or another, or maybe more than one. There might be certain cases where for a specific agent, there is a very particular LLM that is maybe fine-tuned for a task, right? In those cases, then, as part of that agent, there will be that LLM offered or integrated in the solution. But in general, for the most general requirements of an agent, like reasoning or breaking down a task into subtasks and so on, we're going to be using external LLMs. Whatever, it's feasible from a perspective of level of intelligence, but whatever customers choose to use, because there might be customers that say, hey, I have an agreement with, Anthropic, company-wide, and you have to use Cloud 3.7 because that's my corporate LLM. Then we will point towards that. But in other cases, hey, the LLM has to run on-prem and needs to be open source, then it will have to be some LLM from the open source that is good enough for that type of use case. So there's the LLM question, it's always going to be contextual to the use case and what it requires.
Okay, we have a couple of minutes left. Does someone have a mic? Okay, if not, I'm going to ask, answer Vladimir's, or at least ask Vladimir's question, because I think it's an interesting one. So if we perform the same analysis 10 times in a row, toxic factor, config drift, will we get the same answer?
Yes, pretty much.
Yeah, pretty much. Pretty much is doing a lot of work there. I think one thing to be, one thing we all have to get comfortable with is AI is probabilistic. It's not deterministic. So there's going to be a little bit of squishiness. Part of our team is to get model performance to the point it's kind of a small thing, but it's always going to be a little squishy, and that's just the reality. I think we are at time. If you got questions, we're easy to spot in our bright white T-shirts, so feel free to grab us. Otherwise, I thank you for your time.
you.